Welcome to today's podcast. In today's session, we have with us an expert from a field related to batteries. Ramesh Natarajan, a veteran with over 42 years of hands-on battery industry experience, will be asking our esteemed guest a host of technical questions. Hope you find this podcast useful to your business. Enjoy the session. Do visit www.rameshnatarajan.in to stay connected.
Welcome to today's episode of my podcast. I have a very special guest from Italy, Mr. Francesco Marfisi. He is the owner of CAM Equipment, a company based in Italy. And this company supplies machines for making lead suboxide and for curing the battery plates. Actually, both these machines are very, very important because these decide how the active material is in the battery. And so I would like to now welcome Mr. Francesco. For the benefit of listeners, Mr. Francesco, can you just introduce yourself and your company in brief before I start, asking you certain questions about oxide and various things connected with oxide?
Good morning, Ramesh. Thank you so much for inviting me to your podcast. It's very important to share our knowledge about the lead battery and the lead battery industry. So I can introduce me. I am Francesco Marfisi, sales manager of CAM, an Italian manufacturer of lead oxide equipment and curing chambers. In the company born in 1967 from my uncle and my father. Then we have the second generation, and we are developing a lot of new patents on the lead battery industry, and we are making new innovation and new innovating machinery to save energy and to cut the emission in detail for the lead oxide production and curing chambers.
Okay, now lead oxide is the main active material in a lead acid battery, and it has a great role to play, and it also affects battery performance and life. So what, according to you, are the main requisites of a good lead oxide?
The plate of the battery is the heart of the battery. You can implement all the improvements on the lead acid battery, but if you don't have a perfect plate, you have nothing. The first parameter you need to have is to have a molecular structure of tetragonal lead oxide. This fact, unfortunately, is often overlooked by battery technologists.
So you say tetragonal lead oxide is very important, right? Now,
yeah, sure.
In the combination of lead oxide, how much should be the molecular structure of the tetragonal lead oxide, and what should be the other part other than tetragonal lead oxide?
Like Pavlov himself, a Bulgarian scientist, mentioned in his book that the lead battery can have maximum 15% of orthorhombic oxide. But I want to make a step back. There are two types of lead oxide, orthorhombic oxide and tetragonal. Tetragonal oxide is made at low temperatures. Then the orthorhombic oxide at high temperature. The first one, the tetragonal oxide, is made by ball mill. Then the orthorhombic oxide is made by Barton reactor, and
Hmm.
then the sides, the frame of the oxide are
Hmm.
different.
Hmm.
For example, the lead oxide made by by ball mill, it seems like flake.
Hmm.
The lead oxide made by Barton, it seems like spherical.
Hmm.
For this reason, there are some differences on the plate production.
Hmm. So what exactly is the difference due to, suppose now the structure is different, one is spherical and one is flake. So is it a good idea to mix Barton and ball mill oxide and get the best of both worlds? Or do you still say that it's good to use only a ball mill oxide? And if that is the case, with the ball mill oxide, what exactly happens due to the structure? Like, I mean, I know that, the acid absorption values change and something like that, but can you just explain for the benefit of the listeners exactly what is the effect of the ball mill oxide structure and the Barton oxide structure?
The main difference between orthorhombic and tetragonal oxide is on the adhesion from the grid and the paste,
Hmm.
because the tetragonal oxide or ball mill oxide, it's have as a perfect adhesion from the grid and the past. Sure, in the standard production today are still producing both the lead oxide from ball mill and Barton, and then a lot of manufacturers they mix this or mixed by additives. But there are some differences and depends on the battery you need, because the ball mill oxide has a very high acid absorption from 230 up to 260. Then the Barton oxide has a low acid absorption from 160 up to 200. To
Hmm.
summarize, depends on the battery you need, because if you need a, a high cranking power, for example, for automotive
Hmm.
batteries, you need the ball mill oxide. And then if you need an industrial battery, you could use the Barton oxide too, but depends on the goal.
So, can we surmise that a ball mill oxide is good for a cranking battery as well as industrial battery? And do you mean to convey that a Barton oxide is more suitable for an industrial battery but not suitable for a automotive battery, especially considering that ball mill technology is available and ball mill oxide is, if it is available, better to use a ball mill oxide? Is that what you mean to say?
Yeah, because depends on the lead oxide parameter you need, quality department needs.
Hmm.
In the standard procedures, this is the way. But in our experience, after 40 years only on the lead battery industry, we suggest to make oxide by ball mill, because it's better, not only for the quality of the battery, for example, absorption and production and so on, but about the environment too, the energy saving too. There are a lot of points to do. It's not only for the quality. The first
Yeah.
reason, in our opinion, is the quality of the battery, the adhesion of the grid and paste, but there are a lot of other reasons to make lead oxide by ball mill.
So to summarize, we can say that the ball mill oxide has a better structure, and the ball mill oxide has a better acid absorption. It saves more power to make a ball mill oxide compared to a Barton oxide, And from the environment point of view also, a ball mill oxide is better than a Barton oxide, right?
Yeah, yeah,
All these advantages are there with a ball mill oxide.
yeah.
Better
There
adhesion
are,
and better quality.
yeah, there are. You can have the first things is the quality. Then you have a consistent production. This is another important point for the manufacturer, because you can manage your production in 1 year, in 2 years, in 3 years by the ball mill equipment, because today we have very detailed software, automated software can manage everything in detail.
And the variation must be probably in a narrow range. The variation of free lead content and all can be in a narrower range with a ball mill, because you have better controls with the PLC and all these things, right?
Yeah.
Okay. Now, you mentioned something about the temperature, that you are able to control the temperature and have more of tetragonal oxide rather than an orthorhombic structure. Now, I wanted to know whether this is something which not all ball mills have, and this is a specialty of CAM and probably a few others who must be doing it. But is this something very, very important? And are there ball mills in the market where this temperature control is not being done?
Yeah. To come back about the production of the lead oxide, the orthorhombic oxide it's made by high temperature. Then the ball mill by low temperature, by the friction between the cylinder, the lead cylinder inside the ball mill and the internal wall of the ball mill. By friction, you will have the lead oxide at low temperature. But the point is this: there are a lot of ball mill manufacturers, but sometimes you could have some percentage of orthorhombic oxide made by ball mill too, because there are not a direct control of the internal temperature of the ball mill. So you could have some percentage of orthorhombic oxide. Our unique in this, maybe we are the first OEM to make it. I think today there are other brand, they make this more or less, but we born our differential solution is the internal cooling system. We cool the ball mill by spray water inside the ball mill, not external. By this way, we can maintain the same temperature inside the ball mill, so we don't have peak temperature inside the ball mill, and so we don't have orthorhombic oxide, because we control second by second the temperature inside, and for this reason we cannot produce orthorhombic oxide. You know, there are a lot of manufacturers build and design ball mill, but they have an external cooling system by water and not internal. For this reason, if you make the analysis of the X-ray analysis on the oxide, you could find some percentage of orthorhombic oxide. That's it, the reason.
So when you cool internally with spray water, so that spray water does not it doesn't come in contact with the oxide, right? Otherwise it will become a paste.
Yeah.
It does not come in contact with the oxide.
It's a spray water, and it's a company secret how to make the spray water inside. So by the software, by the mechanical system who put the spray water inside, we can maintain the temperature and we cannot modify the oxide and have the good lead oxide then. we have a lot of, then we can talk about our big player customer and so on, but okay.
Okay, I understand. Okay, I just wanted to ask you, I had been through your CAM documents because it was nice of you to send it, courier it to me. I've gone through the whole thing. You say that it is possible to reduce the cost of making oxide. Do you mean you're reducing the cost of making it, or are you implying that the gain which you get, like you put 100 kgs and usually if people are getting 104 kgs, do you mean that you put 100 kgs of lead and in your method you're going to get 105%, 6%? Is that the method, or it's a combination of both?
Yeah. Today, in the last years, we're making 2 new patent equipment to reduce the energy consumption on the production of the lead oxide, and then to cut 100% of the emission in environment. Our first solution is the lead shaver.
Yes.
Lead shaver is the feed material production from milling process. It's a mechanical process who mill the lead ingot. So by this process, we can have the same phenomenon inside the ball mill. Seems like the lead cylinder by foundry, because we don't modify the mechanical structure. For example, like the cold cube system.
The casting of the cylinder, where you melt the lead and then make the ball and then make it hard.
We can save up to 90% of the energy savings. And at the same time, we have 100% of no emission of CO2 and other gas and so on. So for us, it's the real system today to produce lead oxide. About the lead in the blood, when you melt lead, we could have some problem about the operators, and the same thing about the chimney for the CO2 emission and so on. By this system, we found the solution to have a green lead oxide production. Yeah. The second one, but it's made for other process. It's the fast melt. It's an induction furnace to melt lead for the milling process, the gravity casting, and so on. But it's maybe is not today the topic of this podcast. But we have 2 solutions to make the right lead oxide without emissions.
But is the lead shaver a machine which consumes less electricity than a furnace and a casting machine put together?
Yeah, good. We make a lot of studies and our R&D department with our customers found around 90% less than the standard production by melting pot, cylinder casting, and so on.
Okay. And what is the smallest lead oxide mill that you produce, and what is the largest that you have produced till today or you're capable of producing?
Our must-have is the 30 ton, our MOP 30, but we produce the small one is 14 ton, then 24 ton, and the 30 ton.
So
we have 3 sites.
14, 24, and 30.
Yeah.
So 14 tons per day, right?
14 is the smallest.
Yes, it is 14 tons per day in 24 hours.
Yeah, sure.
Yeah.
Yeah.
And the largest one which you have produced till now is 30 tons per day.
Right.
Okay. Now, is there a saving in power if somebody buys a ball mill and does not use the lead shaver? Other than improvement in quality with your oxide, is your oxide mill by itself also capable of saving power in case the lead shaver is not taken along with it?
Sure. You can use the standard because we produce two cylinder casting, melting pot, gas melting pot, electrical melting pot, inductive melting pot. We produce the cylinder caster, and so we can produce feed material how you want, how you need. It's the same for us. For the MOP ball mill, it's the same.
It's the same whether you use this. But then is there a cost saving if somebody does not buy the lead shaver? If they buy only the normal casting and the oxide mill, does it also save cost?
Yes, we in the past we found some energy savings on the melting pot by gas because we install the gas. It's energy saving by fumes. So we install the exchanger on top the melting pot, and we recover the fumes, and you could save up to 25% of energy saving, no more.
In the normal, there is a 25% saving. It's quite high.
Yeah.
Okay. Now, do you have all the test facilities also for checking the oxide in-house, or are they done only by the customer, or are they done only by some outside agency? Or do you also make and test the oxide?
We are OEM of lead oxide equipment. We don't have lead oxide production inside CAM. But at the same time, we tested all our machinery. We test everything before shipping, and then we make the startup in the customer plant up to the commissioning and so on.
So do you make the oxide in your plant before shipping it with each and every bottle that you make? You cannot.
No, we cannot. We don't have the government regulation because we have an OEM and not battery producer. So we don't have the permission.
Yeah, but of course, there'll be standardized procedures, and you have already set how the machine needs to be made. So you're very confident that the machine will directly run when you fit it with the manufacturer, and you're confident about the production. Yeah. Okay. Yeah. Now, when you claim something like tetragonal and orthorhombic, definitely you would have tested it probably on the product made at the customer premises or somewhere, and you are coming to this conclusion that the orthorhombic is less than 10%, right? How exactly is that test done?
Sometimes we have a chemical university close to CAM headquarters in University of L'Aquila, and sometimes step by step we make some analysis on our lead oxide, and so we have we certified our molecular structure, and so for this reason we can say this point about the orthorhombic, tetragonal, and so on.
Okay, so you have already tested it using the services of a university which is near your factory, right?
Yeah.
Okay. Now, I've gone through the testimonials of your customers, and I already have a link. So when I am putting this podcast on air, I also usually put a post, and I will share the link of the testimonials so that in case somebody wants to go through and see the testimonials or understand what exactly your customers say, they can have a look at it or hear the testimonials or whatever it is through the link. But then I also wanted to know, how many, like, which parts of the globe have your equipments been installed? I would like to hear from you. Though I have the testimonials, I know your customers, but still I would want, people who may not go into those links, they can at least, hear.
Yeah, sure. Thank you.
Yeah.
Yeah, today there are 63 MOP ball mills in operation worldwide, and over 200 curing chamber around the world. So to summarize, we design and build all the machinery from lead melting oven up to the flash ovens. You have the testimonial links, and you can read some of our testimonial. But there are a lot of testimonial, inside the CAM box. Yes, to summarize, the most important customer are FIAM in Italy, Excited Technology in Europe. There are over 10 plants in Europe, Moura, Brazil, Willard, Colombia, Stryton in USA, BIA in Germany, Banner, Austria. We have a lot of customer, and then we want to increase our business around the world. Now we are focused in Europe and America, but in the future we want to go in India and so on, because in India there are a lot of manufacturers,
Yes.
Exciting Industry, Amara Raja.
Yes.
Now we are in contact with some manager, and I hope in the future to go to visit your country.
Yeah, I was just wanting to know. So I'm very glad that you said India also. India is a huge market, and there's a lot of scope in India. And with the growth prospects for batteries in India and a lot of exports going on from India as regards batteries, I think you should look at India.
I think so. We will see.
So maybe in January, we usually have an exhibition where all these Indian people gather. So hopefully we'll meet in January 2025. And I look forward to meeting you personally. And
sure.
Thanks a lot.
Send me the link, and then we can arrange this event. Now, in the next September, we will exhibit on the LBC, and yes. I will talk about in the supplier forum the second day about the real case history on the lead shaver and fast melt.
Yeah.
Then I will show you the meeting
link.
So that's it. Yeah.
Okay. So, Mr. Francesco, it was very nice talking to you. And, we talked only about oxide and the lead shaver. But when I got the CAM pack, which you sent to me, so I saw a lot of things about your curing chamber also. And what interested me was about your steam chamber rather than the, water spraying method and all that. So I would like to keep that for the next episode, because I'm sure we can't discuss all together. And I'd be glad to discuss that and have a lot of technical inputs from you as regards the curing also. It was really a pleasure talking to you today. And thanks a lot for agreeing to come on this program. And I'm sure all listeners will also enjoy our interaction and gain a lot from the insights provided by you. Thank you very much, Mr. Francesco.
Ramesh, thank you so much for your invitation. For me, it's an honor to participate with you in your podcast, because I think it's the the most or the first podcast on the lead battery industry, and so it's very important for all the decision maker who want to know better about the lead battery production. So thank you again. Then sure, I want to make another episode about the curing chamber, because we have a lot of things to do about the curing chamber, the steam cure, and so on. So thank you, and so have a nice day.
Thank you. Thank you. But I'm looking forward to the curing chamber, one thing. The second thing, I'm looking forward to meeting you in January, personally. And definitely, I think you must come in January.
Thank you.
Thank you. Thank you very much, Francesco.
Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.